Talk is about Rotel. It's a lightweight and resource-efficient OpenTelemetry collector written in Rust. Let's see. Oh, skipped ahead. Wow. I'm Ray, and this is my brilliant colleague, Mike. We have been working with...
I don't know what's wrong with that mic, so take this one.
Can y'all hear me okay? So cool. We like working with machine data and have been for a long time, storing it, ingesting it, performing analytics on it. We're from Streamfold, and we're basically the team behind the Rotel project. So we're going to talk about a few things today. We're going to talk about the goals of the project, where we're seeing adoption and where it's useful, and a little bit about the developer experience, and then some of the roadmap. So the goal of the project has been to basically unlock places where it's been difficult for people to adopt OpenTelemetry. So we've talked to a lot of users, and we're seeing just a tremendous amount of interest in OpenTelemetry. Obviously, it's the second biggest project in the CNCF, so we see tons of people trying to use it in all sorts of different platforms and services where maybe historically they haven't. So embedded platforms, in AI use cases, agentic use cases, serverless and edge environments. And for those folks, they generally have success getting going with the SDK and getting instrumentation in place, but getting a full OpenTelemetry solution with a collector sometimes presents some troubles. So this is been the approach is how can we basically reduce those barriers for those users where performance or resource consumption is a bit of a barrier for them to move forward with OTel. I'm going to pass it off to Mike here, and he's going to talk more about that, and I'll come back later to talk about developer experience.
Yeah, thank you. So serverless and edge is sort of one of those domains that we saw was users are having a bit more trouble actually using OpenTelemetry and having some barriers around. In particular, I mean, serverless environments are, really tightly resource constrained. You're talking about sort of hundreds of megabytes of memory that you're allowed, fractions of a core, and your runtimes are typically measured in milliseconds. So you really want the ability to have your collection agents really start within sort of hundreds of milliseconds or less in these environments. So a sort of lightweight collection agent is really important in these environments. But it's not, not limited entirely to serverless. So if you look at sort of large Kubernetes deployments, what you'll typically have in many of these is if you're following sort of the sidecar deployment model, you'll have that collection agent deployed alongside your application pods. And in those sort of like leaf node containers, that can scale up to sort of thousands to hundreds of thousands at sort of larger infrastructure scales. So if we can take down even some amount of sort of capacity at that level, even 100 megs, even sort of half a core, that capacity reduction at scale can yield pretty large savings. And the nice thing is then in many sort of these large scale infrastructure deployments, you'll have sort of typically multiple tiers of telemetry collection aggregation and sort of gateway collectors. So you can, at those leaf node edges, you're really trying to sort of collect that data, maybe filter, aggregate it, but then send it upstream over like OTLP. And then, gateway collectors and aggregating tiers, that's where you can push sort of more the expansive exporter integrations, auth requirements out to. But if you can still reduce that capacity sort of in that high scale leaf node containers, that capacity savings can be pretty large. And lastly, if we can build a collector agent that is very small, it allows us the ability to even actually bundle that in as a dependency as part of the runtime. So users can pull in a collection agent as a dependency package using the same dependency tools that they're using to build their app, so Python, NodeJS, which gives the developers then the ability to actually ship their observability tooling with their app. They're owning that more. And yeah, it just makes it easy sort of to manage that along with your existing application and dependencies. So with some of those challenges, you want to introduce what we built, Rotel. So Rotel is written from the ground up in Rust as a OpenTelemetry collector. We have open sourced it. It's Apache 2.0 licensed. Right now, when it's compiled, it'll come down to about less than 10 megabytes compressed. So very small artifact that helps with those situations of pulling it out into serverless edge environments, bundling it into packages. It is OpenTelemetry native, so of course we can accept OTLP data, we can export OTLP data, but internally the data format is OpenTelemetry. We're not converting that into sort of any internal formats. So it just reduces sort of the transitions and schema conversions that need to be done there. So far we've built a set of like foundational components in it, but taking a very user-driven focus on building sort of what people have been asking for in terms of components. And we've also done some work with native language integration, which Ray will get into in a bit here. So yeah, in terms of base features, I mentioned we can receive, export OTLP data. Pipelines have automatic batching. We do retries on failure. And on the exporter side, we have built, again, sort of more sort of user-requested features here. So ClickHouse was actually something that we had pretty early requested support for. So that's actually fully supported for metrics, logs, and traces. We've added support for, and this is opt-in, the JSON column type on ClickHouse. If you're familiar with ClickHouse, this sort of replaces or replaces the map type, which is sort of useful for storing the key value attributes that you typically have on telemetry. JSON sort of extends that with better performance, better query capabilities. So that is the direction I think that's moving. So we do have support for that. And then initial Datadog and X-ray support, both are supported for tracing data. And we have a user actually working through PR that's going to add Parquet conversion with support for both on-disk files as well as uploading that to S3. So yeah, we basically have sort of followed just sort of standard Rust patterns in building this, and the initial implementation we found was pretty good at sort of CPU usage, resource consumption on the memory side. So we've done some initial benchmarking with it here. What we did was actually run this through the Rotel's testbed. We added a little wrapper that allows us to convert a config into the format Rotel takes in terms of environment variables. Link the repo that we're using down there to do that. But yeah, running through the logs, metrics, and traces test beds, there we get pretty good performance. I mean, 75% less memory, about half the CPU usage. And a lot of this just comes from, Rust allows us to sort of expose really bare metal performance, but in a sort of safe and reliable way without risk of undefined behavior. Additionally, the lack of the garbage collection means that the memory usage is, very efficient, and we're not spending time sort of doing sweeps of the heap to consume cycles from that. I said, serverless was one of the areas that we wanted to sort of focus on, and we have, really optimized for AWS Lambda. So we have taken the Rotel collector, we've packaged that as a Lambda layer that's available in all the regions on AWS. By default, it will capture all the Lambda logs, on the container. In your Lambda environment, and we'll translate those into Rotel and then export that to your exporters. That's sort of just nice if you want to avoid sort of the CloudWatch tax and just send that out to your vendor there. Full support for secrets, so you don't have to embed that into your config. And some of the tuning we did do on this was we found that pulling in the AWS SDK actually added a lot of sort of bloat to the binary size and was a bit slower. But the end result is that we've, just sort of out of the gate, we got this down to about 60 milliseconds for cold starts. Definitely some tuning to do here. Comparatively, we were talking with users that were using the the AWS Lambda, and the cold start times on that were just sort of really too slow. So this allowed people to sort of pull back and go back to OpenTelemetry in the Lambda environment, where before that was sort of a showstopper. Part of what we did focus on for the AWS Lambda layer was this idea of adaptive flushing. This is by no means unique. Datadog actually has done a lot of work here in their Rust AWS Lambda layer, so a lot of this sort of follows some of the patterns that they've been following with their work. But generally the idea is that you have to flush data at the end of an execution so that the AWS Lambda, when it's frozen, you don't have data and telemetry locked in that. You want to get that out to your exporter. So naively, you'd flush that at the end, but that extends your execution, both in billing time and potentially incurring additional cold starts. So we do this adaptive approach that if we detect that your execution is more than once a minute, we'll actually try to flush that data concurrently with your execution, which just increases the density of the VM in terms of the executions it can support, reducing your cold starts. So that's sort of features and results there. I'm going to hand it back over to Ray for sort of the developer experience that we've unlocked with this.
Thanks. God, it's so loud. Right, so a little bit about the developer experience, because as Mike mentioned, because it's just like such a lightweight agent, we've been able to embed it, basically. So we have a couple packages, and we've embedded it in Python and NodeJS packages, so it's easy to get going. So, if you're a developer and you want to work with Rotel, maybe you're comfortable with the SDK, but setting up the collector sometimes is a bit more work. It's generally the purview of an SRE or platform engineering, much more sort of comfortable with that. So how do we make it easy for these people to get going with that sort of technology right away? So with packages, you can just pip install Rotel like this, and there's some benefits to that. So as you upgrade the dependencies, you can upgrade your collector, and it's good for platform as a service environments like a railway or like a render, and also good for like local testing. So. And this is just a quick example of what that looks like in Python. So just with a few lines of code, I can import Rotel. This is like, for example, using a ClickHouse exporter and getting it started. And that actually, has the binary included in the package, so it actually forks and execs the collector, and you can just point your SDK right to it and run. So. What else have we done? So other sort of improvements for developer experience is sort of leveraging Rust's FFI.
Is there any way you can get them to talk?
Sorry, am I not close enough? Okay. Yeah, so Rust FFI has, it's designed around zero cost. I mean, it's not really zero cost abstractions, but entirely. I mean, any abstraction is going to have some cost, but that's generally the goal. And what this has done is allowed us to build integrations with other native languages. So we have a Python processor API where you can write processors right in Python, and we're going to dig into that for a moment. Some of the benefits of those, when we call out to Python and we run your processors, there's very little overhead, so there's not a lot of additional things associated with other languages, for example, like stack switching and pinning of memory, or coordination with garbage collectors. So we're using the PyO3 library. It's a pretty popular library for integration with Rust and Python. So I want to show you an example here. So this is an example of using the SDK and writing a processor to redact emails from a log. And you can see here I'm using like It's Rust Rover. It's basically a JetBrains product. But if you have integration with any LSP you're running, basically you have type hints with the package. It brings in all of the OpenTelemetry types, and you can basically see, okay, I'm getting autocomplete. I can see the structure of the data. So here I have resource logs. It contains scope logs. I'm looking at the log body here. We're writing a function to redact emails from the body, auto importing of values, and just basically gives you the experience you would expect as a Python developer or as a developer in an IDE writing processors. So this is pretty nice. Let's see, what else to talk about there? You can basically just do all the things that you would normally expect, so go to definition and all those sort of things. So let's take a look at how does that happen though. So most Python to Rust integrations with PyO3 are generally one way, and they're generally, you have a bit of Python and you want to speed that up by doing some compute heavy processing in Rust. So you generally define like an API, and then from your Python code you're calling into Rust, and that's how you're getting the performance optimization. For this, it's actually a bit more difficult. We're actually going, and it's not that common, but going from Rust into Python. But we actually go from Rust into Python, back into Rust, back into Python. And so what we've done is, several times until the processor's done and the data exits. So this is giving you like a little, this is a diagram of the flow of the data. So as Mike mentioned, the data internally inside Rotel is just OTLP format, and it's like in the protobuf format. We've loaded it up into memory, and we convert it to basically a Rust type that basically makes it shareable with Python. So basically, we wrap it in these things called arc mutexes, which allow us to very sort of efficiently just clone references to these data types. And then we have a small set of wrapper libraries in Python that when you call from your Python code, you say, I want to look at the resource logs, I want to look at the scope logs inside the resource logs. It's calling back into Rust, right? So it's calling into Rust, and it's these lightweight Python types. And what's really nice about it, the way it's implemented, is you can literally write like idiomatic Python while you're doing this. Like I said, a lot of other APIs will be like, here's an API, to speed up something in Python calling back into Rust, and you have to learn the API and all the functions. When you write this, you write pretty much just like idiomatic Python. And then on the way out, we basically take the data out of those Rust types, turn it back into OTLP, and send it along. So let's see. So in that previous example I showed you of like redacting email and writing it in a Python processor, like here's how you can do it like with the transform processor. Pretty straightforward in the current collector. Here, I don't know if you can see that yet because it's like looks terrible up there. It's pink or whatever. But basically, we have a redactor basically with a regular expression saying replace this pattern on the body of a log. So that's pretty straightforward. Just we ran some like load tests on this just to get an idea of what the performance looks like when you're writing these. From a CPU was great actually, so the Rotel performs pretty good on that. On the memory side, once again, it's less memory, but it's almost as close as the collector. We've done a fair amount of optimization on the processors, but there's still a lot of low-hanging fruit and a lot more work that can be done. So one of the things we do to optimize that whole processor space is if we're lazy about converting the data into all these types, because that eats up a fair amount of CPU, basically converting it to these different types and going back and forth. So if you're not accessing the data, we'll wait, for example, to convert it into the type to expose it to Python. And in the future, we're probably going to introduce, basically take advantage of Rust unsafe and basically use raw pointers to do this, and we'll have a significant performance gain. So overhead should be very, very minimal at that point. Okay, we're almost out of time, so I gotta get going. We also have a bunch of pre-built processors. This is probably impossible to see, I can't tell from here, but a bunch of pre-built processors out of the box. So that shows you how to get going with the Python API. Great examples of how to write some. And we're also writing Rust native ones for things that are performance sensitive, like tail sampling and stuff like that. And it's easy to get going with Rotel, so we publish pre-built binaries, Docker images. As we mentioned, you can just pip install and just get going in a Python app, Fast API or a Flask app, the Lambda extensions, and pre-built binaries on the GitHub. Want to talk about what's next?
Sure. Yeah. So yeah, wrapping up on what we're looking at, sort of working on next. Obviously, we want to expand additionally on the receiver side and exporter side. This is where we're still sort of taking a user-driven focus. Still love for people to take a look at the repo, open issues, or talk about what's sort of important for what you'd like to see. Additionally, we want to build more processors, both using the sort of Python integration, but as well as, Ray said, sort of expanding. If we did build something purely in Rust, which would be sort of the ultimate higher performance option, what could we build there? Again, things like maybe tail sampling, which would be a bit more expensive, would be worth doing there. We've been watching the Rotel Arrow effort, and definitely I think Arrow as a format presents a lot of significant opportunities for improving pipeline efficiency. Very much sort of well designed for telemetry data, OpenTelemetry data specifically. So watching that effort, nice thing is a lot of the libraries Arrow based are Rust already. So incorporating that into Rotel would be pretty easy to do. So taking sort of a look at that and where that would fit into sort of the pipeline process. And then of course every deck needs to mention LLMs. So taking a look at what sort of agentic workloads look like and whether a very small bundled collection agent is useful in sort of this domain and for those workloads. So, would love to talk with anybody sort of working in this space in terms of, what's needed and what are the sort of biggest challenges there. Love for you to come check it out and let us know what you'd like to see next.
Time for questions? Yeah, we got a couple minutes. Yeah. Oh, gotta get the mics.
Yeah, I know, right? I've been here enough times. So kind of two related questions. First one is the 10 megabytes compressed, the binary, is it fully statically linked?
No, that is dynamically linked.
It's dynamically linked,
Yeah.
okay. So I guess that kind of answers my next question of the part of the reason that the Rotel collector binary is so big is just Go being Go, but the other part of it is that it is fully statically linked, and as more components get added with more dependencies and stuff, it grows and grows. And so as you're adding more components and stuff, is this going to start to be a problem for you embedding in a pip install? Like, even if it is statically linked, I assume there's a bunch of dynamic libraries and stuff packed together.
Great question. Yeah, so I think it's minimally dynamically linked. So libc is dynamically linked in there. We have a Python, so if you're using the Python stuff, it links with libpython, so we have builds for that. This is a question we've been thinking about as like, all right, obviously as you add exporters and components, this is going to grow.
Right.
One of the directions we think we want to look at is building those exporters as like DSOs, dynamic shared objects, and more at runtime sort of linking those in. So you would say, I want this exporter, here's the DSO for that, and pulling that in sort of at runtime. That would limit sort of the base build minimally, and then you're pulling in just sort of what you want exactly from that.
So that's my biggest frustration with the collector as it is today, is the custom plugin story.
Right.
So like if plugins themselves were dynamic objects all separately loaded at runtime, like that could open up the custom plugin ecosystem.
Go had the ability, I think they've removed it now, but they had the ability where you could
It was
compile.
Linux only, and it's gone, and it sucked.
It's
and
gone. It was,
yeah.
and I tried using it. It was a nightmare because if your tool chain wasn't the exact same, like it didn't work. But and we focused mostly on OTLP right now and just trying to keep it as small as possible. But yeah, it's a problem we need to think about.
Yeah.
So.
Even just
question.
managing crates that duplicate and trying to like shrink the size there is.
With the Python, so the Python processor API, we disable it by default. So it's a feature flag, and then so we provide builds specifically for that, and then builds for which version of Python and architecture you're on. So it's just to keep it small. What else?
Thank you.
Yeah.
Who's first?
Yeah.
So part of the definition of what an OpenTelemetry collector is that it supports its configuration file. You touched on having a wrapper for being able to like embed Rotel in with the testbed. I'm curious what your plans are for supporting that config file.
Yeah, so right now it's purely environment variable configured. A lot of that overlapped with doing on Lambda. I made that sort of easier, but yeah, I mean I think we will want to get to a point where you could pull in an OTel collector config because the parity is very far off. We didn't want to sort of look at that just yet because it would not work for most cases.
I mean, there's
but yeah, I mean I think we want to go in that direction. Mixed with sort of some of the sort of native language integration configuration as well. But yeah, I mean, would probably go in that direction.
So I'm curious more about that kind of direction and how you're thinking about it. Like, how opinionated are you planning to be about kind of what goes into the project, what doesn't? Are you going to have hard constraints on performance or resource limits or not? How do you, will it just keep growing until it's own ecosystem? Like, how are you thinking about this?
Like I said, Mike and I are opinionated. We've worked on systems at scale. I most recently worked on Foundation DB at Snowflake and Segment. Mike at Netlify. We have a lot of firsthand experience scaling observability platforms and the difficulties of that. And we find ourselves again and again often building or rebuilding with a certain amount of mechanical sympathy. So we are opinionated and we are focusing on performance, but it's very early right now, and we're just trying to find our users that are in getting value out of this in places where they couldn't. So for example, the serverless folks, they just couldn't run the other stuff that was there. Focusing on those people, building the community, listening to them. We've got our first pull request from a user the other day that forked. So it's still pretty early, but it's going to be part of the community building process and defining that as we go. So.
Yeah, part of doing this talk today is sort of try to grow a community and sort of get more of those voices in there that it's not just us and sort of the few initial users that we found.
This is the first time we've actually talked about the project at all. So we haven't. This is So the people that are using it today, we've just like through friends and networks, GitHub issues. Hey, this is out here. Try this out. So this is actually somewhat of us, announcing, hey, we're working on this thing. So if you're interested, let us know.
All right. Well, thank you all, and
Thank you.
see y'all later.